Hi there, and welcome back to another Papetti Math YouTube video tutorial, where I'm going to be teaching you, yes you, Algebra 1. And in this video, we're going to be taking a look at exercise number 3 that says h of x is equal to the absolute value of x plus 3. But let's not ignore what we just did in exercise number 2. In exercise number 2, we looked at the absolute value of x minus 2, and we saw that this was shifted 2 units to the right. So we were subtracting 2, and it moved it 2 units right. So if the opposite of a subtraction is addition, and subtracting moves it to the right, where do you think addition is going to move it? And you might have guessed left, but let's see. Let's make sure that it's moving to the left. So we're going to have x and h of x. This time we're going to start at -5, -4, -3, -2, -1, 0, 1. That should be good. Okay, so we're going to do -5 plus 3, and we're going to get -2, and the absolute value of -2 is 2. We're going to substitute a -4 for x. -4 plus 3 is -1. Absolute value of -1 is positive 1. -3 plus 3 is 0. Absolute value of 0 is 0. -2 plus 3 is 1. Absolute value of 1 is 1. And look at that, there's our values repeating. That's perfect. -1 plus 3 is 2, absolute value of 2 is 2. 0 plus 3 is 3, absolute value of 3 is 3. And 1 plus 3 is 4, absolute value of 4 is 4. So again, I substituted in my x values into this function to get my h of x values. Now I'm going to graph these on the grid and see what kind of shape I get and where it's located. So I have -5, comma 2. I've got -4, comma 1, -3, 0, -2, 1, -1, 2, 0, 3, and 1, 4. And there I have my absolute value function of h of x, the absolute value of x plus 3. And again, I'm going to connect these points using those straight lines. And I'm going to put arrows on the edges of those lines to show that that goes on forever. And your v doesn't always have to be symmetrical, just as long as you show that point called the vertex, as we talked about in exercise number 1. And we want to look at where this vertex was shifted from our parent function of f of x, located up here. Where was this parent function shifted? And you have to take a look at the vertex started out here and it ended up there. So that's 1, 2, 3 units to the left of f of x. So now we could determine that we might be developing some sort of rules here. If we're subtracting a number inside the absolute value, it's going to shift your absolute value function to the right. And if you're adding a number inside your absolute value function, then you're going to shift that absolute value function to the left. There's going to be many more rules that we're going to learn in this lesson and the next lesson. But for now, if you're subtracting inside, let's move the function to the right. If you're adding inside, let's move that to the left. I like to think of that as an acronym called Sir Ale, one of the lesser known, or for that matter, less popular knights at the Round Table. He was Sir Ale, next to Circumference, Sir Lancelot, and all the other knights of King Arthur. So we have Sir Ale, and I write Sir Ale because this is an acronym for subtracting inside moves to the right, while adding inside moves to the left. So if you ever have to think of your shifting rules for absolute value functions, think of Sir Ale. It might help. That was exercise number 3. And before you go on to exercise number 4, just give this video a thumbs up to let me know that I helped you out with your absolute value transformation rules. Thank you for watching.